my eyes. Yeah, you can see the reflection of my glasses. Right. Yeah. All right, I guess it's time for us to get started. First of all, welcome to the Faculty of Science Information Night. Good evening, future students. Welcome to our Faculty Information Night. I hope everyone is doing well this evening and you're ready to learn about our program and all the opportunities that are available to students. We are so pleased that you are considering the Faculty of Science as a next step in your educational journey. So just as a reminder, if you could make sure that your mics and cameras are off during the first part of our information night. And then when we go out to breakout rooms, you can turn on your camera and your mics then if you have questions that you would like to ask. Before we begin, I would like to take this opportunity to acknowledge the traditional territories of the people of the Treaty 7 region in Southern Alberta, which includes the Blackfoot Confederacy, comprising the Siksika, Piikani, and Kainai First Nations, as well as the Tsuut'ina First Nation and the Stoney Nakoda, including the Chiniki, Bearspaw, and Wesley First Nations. The city of Calgary is also home to Métis Nation, of Alberta Region 3. I'd also like to say that the city of Calgary is home to the University of Calgary is situated on land adjacent to where the Bow River meets the Elbow River. And that traditional Blackfoot name is Mohkinstsis, which we now call the city of Calgary. So first of all, I should introduce myself. My name is Nancy Chibri, and I am the Associate Dean for Undergraduate Programs and Student Affairs for the Faculty of Science. And today I'll be your MC. And I'm zooming out from my home, so I apologize if you hear some dogs barking in the background. So we have some fantastic presenters here with us today, and our event will start with short 2 to 3 minute presentations by representatives from each of our departments and programs, and we'll follow those with a breakout room session. The quick presentations will give you a general overview of why you should choose a specific, can't say that word tonight, department or program. And the separate breakout rooms will give you more in-depth information about the departments and programs you're interested in. You will also have the opportunity to ask your questions during those breakout sessions. So before we start the pitches, I would like to share a student resource document we put together for all of you. In this document, you will find links to admission requirements, program information and guides, fees and funding, student supports, and much, much more. So hopefully it's showing up in the chat for you right now. And if people are joining us later, we'll keep putting it up throughout the chat so it's fresh. And we'll put it up again at the very end of the 2 to 3 minute presentations. So just a reminder too, we won't be discussing admission requirements this evening, but we encourage you to review our document. If you have any admission questions, please connect with the undergraduate and recruitment admission team. We have contact info for this team on that resource doc that we've posted. And you should see the document now. So if you want to download a copy, save it for future reference, please go ahead. And again, just a final reminder, please make sure that your mics and cameras are off during this portion of the event. All right, well, it's time to get started. So I know you're all excited to learn more about the Faculty of Science. So our presenters will introduce themselves as we move through the pitches. We have representatives from biological sciences, chemistry, computer science, geoscience, mathematics and statistics, physics and astronomy, data science, environmental science, nanoscience, natural science, and neuroscience. So please join me in welcoming our first presenter of this evening. And that person is from the Department of Biological Sciences.
Well, good evening. My name is Bernadine Holland. I'm actually a research assistant in the Department of Biological Sciences. And I didn't do my undergrad at U of C, but I have really enjoyed my time there. So biological sciences is a very, very diverse area. So I'm gonna blast through a lot of stuff in the next little bit, basically covering everything from biomolecules to biospheres. And just before I get started, I should just mention you can do either the Bachelor of Science or the Bachelor of Science honors program in our program. So I need to click the slide ahead here, and okay, here we go. So we offer the 6 programs in biological sciences, 6 very unique programs, like I said, from biomolecules to the biosphere. And I'm going to start with the first of these, which is biological sciences. In the biological sciences program, the first, oops, sorry, I dropped something. Okay, in biological sciences, this is a really diverse program, and it's the most broadly based biology program that you can take, or biological sciences program. You'll develop a general overview or a good overview of several aspects of life. Why would you choose biological sciences? Well, you might ask a question like, how does an ecosystem remain productive? You might want to know, how does fungi work? You might want to know how single-celled organisms live their lives. And so really it's a broad program with respect to what you can do in biological sciences. Again, also being that it's so broad, you have nice career opportunities when you're done. You can work in environmental management, you can work in conservation, you can work in research and biotechnology. Just to tell you too, these programs, many of them are also good stepping stones into the next, or into, if any of you want to do any of the professional programs, so in medicine or dentistry or veterinary medicine. Biochemistry is our next one that is a wonderful program to take. And this basically looks at the chemistry of living organisms. So it's the molecular basis of living organisms and how changes occur in living cells, essentially. So you'll learn how to unravel the complex systems of the chemical aspects of how life forms function on a chemical basis. Why would you choose this? Well, you might ask a really neat question like, how does a firefly's abdomen, how does bioluminescence work, for example? Or you might be looking at something about disease, like what about mad cow disease, and how can this disease be treated, or what is the basis of it? You might also be looking at how some really cool bacteria can survive in really, really hot environments. This degree will give you opportunity to get into some newly evolving fields too, like bioinformatics, for example. And the career opportunities, again, are really kind of timely and really great. You can get into things like biotechnology, toxicology, clinical chemistry, animal sciences, and many, many more. And again, this degree too can be a stepping stone to some of the professional programs if you're interested in that. The next one to look at is the cellular molecular biology program. This one, you can get a really strong foundation in contemporary microbiology and cell biology. So looking at things from the single cell and the micro level. So this is the emphasis, essentially, the molecular mechanisms that regulate cell function, essentially. So why would you choose this? We're ahead of ourselves there. Sorry about that. Why would you choose this? You might even ask a question like, how does a cell or a bacteria function? How do cellular processes influence our lives? Can the genes from one organism be transplanted into another? So some of this is really cool, timely research or interest that you might gain a founding for. Many global opportunities to work in this, everything from biotechnology to medical research, toxicology, and again, more. And again, another one of these programs. It's great for prerequisites to get into some of the professional programs. The next one is ecology, which is my particular area, or an area that I obviously have a love for. This allows students to study the processes of basically how animals are distributed in nature and how plants are, how ecosystems work. So it allows students to study the processes that determine the distribution and the abundance of plants and animals, also in natural and both non-natural worlds, human areas too. It'll teach you how to look at the underlying mechanisms and function of ecological systems at all levels, and what's responsible for diversity in life. Why would you choose this? Well, of course you choose ecology, but you might want to ask a question like, do wind turbines that we're developing now, do they affect bats and the survival of bat or migration of bats? Or you might look at things like, how is climate change affecting fish populations or mammal populations or the distribution of animals? This is really cool because in addition to learning in class, you're also going to have the opportunity to do a lot of field work. One of the opportunities is a 2-term research project where you get to go and really get into your science. The career opportunities, again, are quite numerous. You can work either in the global level, working in conservation research. Some people are working in forestry, also in the public sector, and also research as well. And in the public sector, sometimes in the nonprofit as well. Plant biology, that's the next one to breeze through. I'm so sorry this has to go so fast, but why would you choose this? Well, you might ask a question like, how is the environment affecting crops that are growing? Or you might even want to be looking at plant medicinal properties, which is something that is very interesting as well. You'll have the opportunity, again, in this program to participate in one of those 2-term projects that you can develop, and some of our students even end up going on to do research in our own departments. Again, global opportunities to work in a lot of areas. It'll also be another one that could be used for stepping stone to graduate school, especially. And then also different aspects of looking at forestry and whatnot from even a law perspective. And then the last one to talk about is zoology. This is a very diverse area, as you can imagine, because there's so much life on Earth in terms of zoological. But what we do basically in this program is we're looking at both the morphological and the physiological aspects of animals, so the anatomy and the physiology behind, also the taxonomy of animals, so the classifications of animals. Then this will, we have people that have done everything, that gone on to study everything from tooth wear in certain mammals to paleontology. It's another area that you can work in. So that's a really broad area, really quite. So you could be a paleontologist, you could work in conservation, you can work in research. So just to sort of shore this up, if you want to get into any of the more detailed information about each of our programs, this is our link. And then each of those programs will give you a link to the very detailed courses that you're going to need to look at. We also, just before I'm just going to breeze really quickly through this, we do work with some pretty amazing facilities, such as the Banfield Marine Sciences Center out on Vancouver Island, also the Geoscience Institute here outside of Calgary, and the Advanced Canadian Wastewater Assets that works with the City of Calgary too, where they're involved in looking at wastewater toxicology and such. And then the Conservation Research Center with the Calgary Zoo, which is pretty exciting. They're really focused on endangered species. And then finally, this is just some slides to show you how much fun our students have when they're engaging in these really exciting courses. And also, one other thing to mention is some of them get to go overseas too on some of the exchanges. And that's the reason why you should do this, is biology is life, and you just moved on.
Yes, we went a little over time, so we have to move on to chemistry. So thank you so much, Bernadine. That was awesome. Okay, so next we have chemistry.
Hi, I'm Belinda Hain. I'm a professor in the chemistry department, and I'm really delighted to be here and to talk to you all about chemistry. So you're going to hear quite a lot. So if we can go to the next slide, so why we should study chemistry. Can you go to the next slide? Chemistry is really a central science. And you're going to hear that a lot from the other, but they are lying. Chemistry is really the central science. And so really what we are studying is we are studying all the properties of matter and how matter is changing. But I would say that chemistry is probably the science that everyone is already doing. If you can go to the next slide, because cooking is chemistry, and even using your microwave to reheat some pasta, this is making chemistry. But really what you're going to learn through chemistry is really those properties of matter and how you can apply that to maybe, on the next slide, create new material that can have lots of application, and in particular right now application to combat the global climate crisis that we have, by finding new material, for instance, to capture solar energy, or new material to capture CO2 and really reduce the pollution on Earth. But you can as well be the next generation of people creating new drugs, new antimicrobial drugs or antibiotics that are going to be extremely effective. Or right now, doing some research, if you can go to the next slide, which are saving the life of people by basically decontaminating masks which have been infected by COVID. And those are right now researched on in the chemistry department at U of C, which are translated into low and middle income countries. If you go to the next slide, what is very important with chemistry is that you're going to gain all that knowledge about like chemical reaction, matters, and how to create them and how to transform them. And you're going to obtain a degree, which even when we have a high employment rate, chemists are still going to be asked in high demand. And so you're going to be like, yes, I'm going to have it, but what can I do with it? On the next slide, sky is really the limit. You can do whatever you want with a chemistry degree. This is probably one of the most versatile degrees. If you go on the next slide, you can go to medicine. Yes, medicine is a very good route. Chemistry is a very good route to go to medicine. You don't have to have a bio degree in order to go to medicine. You can go to law, dentistry. Obviously, vet med, I forgot to mention it here. You can go to business school, you can teach, you can become a science writer, do some outreach, or you can simply go to graduate school and become a prof, exactly like me here. On the next slide, here are a couple of our alumni. We have Erica Kimley. She did her undergrad at U of C, and she became an MD. She went on to Harvard to study medicine, and now she is like an emergency ultrasound specialist, and she's working in low resource center. And she basically fell in love with chemistry. Sophia Ross is an undergraduate and a graduate student from U of C who went on and moved to law school at U of S. And she really loves studying chemistry for the problem solving. So you see there is a lot of things there. Jerry Commodore came from Ghana to study chemistry at the PhD level here at U of C. And he really wanted to study to contribute positively to the climate crisis. And he did that during his research, but he's now able to do it and translate it into his job because he's a laboratory manager at an industrial climate solution. Shona Shechtel, she did her bachelor here at U of C. She's a graduate student in my group. She's completing her master, but she wanted to be a teacher, and she's going to start a PhD in chemical education. And really for her, chemistry, it's all about the community that you're building. Roger Ma is like both undergrad and graduate student and from the U of C, and now he's like VP research from a company who is really working on climate change and sustainability, and this is what he wanted to do. He found chemistry was very powerful for that. And then Shining Chang, she has a BSc with honors, so you can have an honors as well in chemistry, and from the U of C, and now she's like a graduate student, and really she wants to be involved in innovation, and that's why she's studying chemistry. So I hope that maybe you're going to be the next generation of chemists graduating from U of C. Thank you very much.
Oh, thanks, Belinda. Our next speaker is from the Department of Computer Science.
Okay, thank you, Nancy. So good evening. I actually don't have any fancy slides, so you can just relax and close your eyes and just listen to what I want to say. My name is Christian Jacob. I am the head of the Department of Computer Science. And I want to answer the question, why is computer science a really exciting choice for you? Well, first of all, computers are everywhere. And I would like to give you a few example areas where we see some really close relationships to computer science. So example one, because computers are everywhere, how can we ensure that in the internet and the social media, our data remains private and secure? You probably know about the latest discussions around Facebook or Meta as it's called right now. Then we look at, for example, new digital currencies. What is all the hype about Bitcoin? How can new cryptocurrencies be created? And what role does blockchain technology play? Where else can blockchain be applied? What about self-driving cars? What is necessary to make cars drive by themselves? How do they interact with other cars or with pedestrians? This gets us into computer networking, data analytics, video processing, and machine learning. Well, machine learning, which is actually an area of artificial intelligence, what is the difference between AI and machine learning? Will robots actually take over the world eventually? In computer science, you will learn about the basic tools to use for effective data analytics, robotics control, search, optimization. So basically everything about AI and machine learning. Then there is the question about how we interact with computers in general. How can we go beyond the keyboard, a mouse, a touch screen? How do we build so-called tangible user interfaces to merge the virtual and the physical worlds? And nowadays, we often talk to our computing devices by speech. So how do these natural language processing interfaces work? How can we use computers as tools to bring people together for remote collaboration, for conversations, for creative work? And what are the ethical and social consequences of this? Talking about digital worlds, how do computer games relate to computer science? Well, here we look at computer graphics, rendering, display devices, 3D modeling, lighting, storytelling, large-scale simulations, and lots of more things. Talking about computer games, content streaming relies on cloud computing. Edge computing, distributed computing, and other technologies are used for video streaming, game streaming, esports, you name it. And closely related to this is, how do we program the so-called Internet of Things? That means things that are connected, that can communicate, that can make decisions, that can even be hacked into. And in order to explore and be competent about all these topics, we need to understand the fundamentals of computers. So for example, what is computer architectures? How are they built? What are these processing units? What are their communication protocols? What are data structures? How are data represented? What are databases? How do they work? And also, what programming languages exist? How can we program computers? And why are there different programming languages? So computer science ponders these questions and even bigger questions, such as, for example, what can be computed on our current computers? What will or does quantum computing bring? Is our brain a quantum computer? What kind of computer is it? So in general, computer science is about how computers can help us solve problems, how we can use computers as think tools so that we become smarter, can get better, and make more informed decisions. So that's computer science. And what else can be more exciting? And we can talk more about in our breakout session.
Thanks, Christian. That's awesome. Okay, our next speaker is from geoscience.
Good evening, everyone. Thank you for attending this session. My name is Rajiv Nair, and I'm an instructor in the Department of Geoscience. When I was asked to participate in this section, I thought about the time when I had to make a decision about what to choose at the university. I was really good at science subjects, but I wasn't really sure exactly what I wanted to do. I'm sure many of you are actually in the same boat. So a few months ago, we actually did a review of the Alberta curriculum. So if you are from Alberta, I will not blame you for probably thinking that geoscience is about, distinguishing a rock from a potato, because it turns out that the Alberta does not actually have a lot of information about geoscience, which is why I'm here to tell you about why you should consider taking geoscience at this university. Next slide, please. If I think back to what attracted me to science, next slide, please. One of the things that stood out for me is that the scientists actually made a difference in society, right? Scientists are creative thinkers, and they're very creative problem solvers. So perhaps many among you are also interested in science because you want to apply your knowledge and skills to make a difference in society. So in that sense, when you think about the grand challenges of the society today, whether it is climate change, or it is dealing with natural disasters or managing them, or whether it's water quality problems that pervades not just developed worlds, but also underdeveloped worlds, talking about energy transition, or even thinking about sustainable technological innovations of the future, we have to be informed about the various Earth system, and the geoscientists will play an important role in solving these major challenges. Next slide, please. If you ask a good scientist, they would always tell you is that if you want to solve a major challenge, the first thing to do is to actually understand that problem. Okay, and this is in fact what we do in geoscience, right? We teach you to collect information about the Earth and how to solve problems, and this involves collecting data in the field or using your natural senses, but also sometimes going beyond your senses and using state-of-the-art equipments to collect data at the microscopic and submicroscopic level to then use that data to actually make the models about the Earth and the natural world. Next slide, please. And one of the beautiful thing about geoscience is that it is actually truly an applied science, because we don't really have a very different scientific concepts, right? We actually apply principles of other branches of science like chemistry, physics, and biology to basically study the Earth. So many people think that you don't really have the right background to go into geoscience, but you do. If you know a little bit of chemistry and you know a little bit of physics and biology, geoscience is actually the perfect place for you to be, because you can apply all that knowledge that you actually have for problem solving. Next slide, please. And so geoscience, I would say, is actually the key to solving many of the technological problems, right? Basically finding the raw materials for the technological innovations of the future, and particularly developing a sustainable society. Next slide, please. And geoscience is truly a global science, right? What we teach in our programs will actually take you to places, right? It's truly transferable skills that you can take to anywhere in the world and apply. And next slide, please. So we're going to provide more information about the details of geoscience in the breakout room. So we're hoping to see you there. And there are some wonderful people, including Dr. Jen Cuthbertson, who is the Associate Head of the Department of Geoscience, and a couple of geoscience students, Sarah and Julia, waiting there to interact with you. So I'll stop there. Thank you for listening.
Thanks, Rajiv. And we're on now to the Department of Mathematics and Statistics.
Hi, everyone. My name is Lauren Didju. I'm an instructor in the Math and Stats department, and I'm going to tell you a little bit about our majors. So we have actuarial science, general mathematics, as well as mathematics. In the actuarial science program, students explore the world of financial risk. So questions that they might ask is, how is the premium rate of flood insurance calculated, or can insurance companies cover all of their claims? Students in the actuarial science program often go into insurance or quantitative finance or consulting. Another one of our majors is the general math combined with a Bachelor of Education from the Workland School of Education. So students in this program get both a math degree as well as a BEd, so many of them plan to become school teachers. And then finally, our third major is mathematics, where students explore the beauty of mathematics. In your first couple of years, you would take a lot of different math courses like applied math, pure math, and statistics. And then in your upper years, you would kind of see which of those things you like more and maybe focus more on those. Career opportunities include data science and analytics, software development, public policy statistics, as well as academic research. So really the wonderful thing about mathematics is that it teaches you how to think. So with the math degree, there's really so many career opportunities that are open to you. Many of my peers who took math as well have gone on to things like be a doctor or a lawyer or a data science analyst for a sports team. So there's really like lots of doors that open to you with a math degree. In our department, we have a really vibrant undergraduate community. We have great student clubs and places to work. And there's also lots of opportunity to engage in, on the next slide, we have summer research as well as teaching assistant opportunities and lots of opportunities to engage in enrichment and outreach initiatives. So on this slide, you can see one of our former undergrads, Taylor. She's presenting at a conference in Hawaii where she did summer research. And on the next slide, we have one of our former math majors, Kim, and she's working at an outreach program, volunteering there for girls excel in math. So I would say the best thing about the Department of Mathematics and Statistics is the people. So it's a really friendly department and great community. So if you join our breakout room, we have 5 undergraduate students here today that'll tell you more about our majors, and they're there to answer any questions that you have.
Oh, okay. Thank you, Lauren. Under 2 minutes, that's impressive. Our next presenter is from the Department of Physics and Astronomy.
Hi, folks. Hopefully you can see my screen. My name is David Fader. I'm the Associate Head Undergraduate in the Department of Physics and Astronomy, and I'm here to tell you why FAS, as we call it here, is obviously the best department in the Faculty of Science. The organizer of this event, Ashley Trombley, suggested that presenters use one of the PowerPoint templates that she made available to us, and this is one of them. Maybe you've seen it already at the beginning. As soon as I saw it, I realized this actually represents FAS really well. Everyone starts their programs learning about forces, and this apple represents the huge leap in our understanding of the force of gravity, for example, driven by the experiments of Galileo, and then, of course, Newton, who also invented calculus to describe the world around us mathematically. And our courses cover a huge range of topics, leading right up to the present day, represented here by the atom. Think about quantum computers, or the Northern Lights, or the center of stars, or advances in medical imaging technologies. These are some examples of the active research areas that are actually being undertaken in our department right now, and you can be part of that as an undergraduate researcher. We have many opportunities for you to participate in research throughout your degree. And all of these derive from our understanding of the world at atomic scales. And not only do we literally talk about gears and how they can make your life easier, we provide an environment where you practice many relevant tools that you can apply in your future careers. And for example, we have many interactive labs associated with the courses that you're taking. All we need really is a thermometer in this flask, and we'd have a calorimeter lab. And we have an entire stream of courses that are focused only on hands-on technical skills that will culminate in building and controlling really sophisticated instruments and technologies. And we have an entire suite of courses as well devoted to coding in Python to simulate physical systems, giving you the programming and big data analysis skills that will make you extremely attractive candidates for technical careers. My point is that physics is not all about book learning, although in physics and astronomy, our books are arguably the biggest and heaviest. You also really get to play. You get to design and you get to be creative. For example, a brand new makerspace that's shared with the Department of Computer Science is coming online this winter term with 3D printers and electronics workstations, a sewing machine, high performance computers, a host of other prototyping and building equipment. I've even heard rumors of a piano. But really the most important and special thing about FAS is that we get to know you. We have all kinds of committees and groups to build your relationships with one another. For example, PASA, the Physics and Astronomy Students Association, actually the president is in the house, and you'll have a chance to talk with her in a breakout session for physics and astronomy, but also to interact with faculty and staff. We want to hear from you, and we want to change what we do based on your feedback. So I hope I've convinced you that FAS is the heart of the Faculty of Science and where you should be. Thank you.
Thanks, David. There we go. Can everyone see this? Good. Okay. Thumbs up. All right. I see thumbs up. All right. Our next presenter will come to you from the data science minor.
Hi, good evening, everybody. My name is Matthew Greenberg. I'm an associate professor in the Department of Mathematics and Statistics here at the U of C, and I'm also the co-director of data science programs in the Faculty of Science. Whoever's controlling my slides, I have the next one.
And the next one?
Next one, yeah.
Yeah.
I'm still seeing the title slide, Nancy. Still seeing the title slide. Yeah, that's good. It's the PowerPoint view, but it'll serve. Okay, great. So what is data science? So unlike the previous presenters, I'm not here representing a department, and I'm not here representing a major field of study for your undergraduate program. This is a minor program, which means sort of an add-on to whatever your principal field of interest is. Data science itself, though, is a multidisciplinary, a transdisciplinary subject, incorporating aspects of math and stats, of computer science, and of any other scientific domain, be it chemistry, physics, biology, or any of their subspecialties that you might be interested in. Okay, so this data science is a subject, and it's also a set of tools, and we study data in all its aspects. We like to say that data has a life cycle. We study all aspects of the data life cycle: capture, maintenance, processing, analysis, and communication. And all of these different parts of the data life cycle have their have substructures. In communication, you have data visualization, which is a science unto itself, and the analysis of data. That's where you get into a lot of very interesting statistics and mathematics and powerful tools from computer science. In the processing and maintenance, there are also powerful software models that come into play, machine learning models, information retrieval models, and all of these aspects are touched on to some degree in various parts of the data science minor program. Why would you want to study it? Well, data is fundamental as an object of study in its own right, and also fundamental as an object of study in all of the sciences. You'll be studying data in some form, be it collected from a lab, observed in nature, scraped from the internet. You'll be studying data regardless, so the skills are undoubtedly useful and flexible because of the multifaceted nature of data, all the different ways it arises in our study and in our lives. Again, this is a minor program. It's meant to be complementary to your major field of study and to enhance your workflows and your workload, and also not to be minimized, the fact that these skills are extremely marketable and desirable from the point of view of employers these days. After your lives will not end with your bachelor's degree, they'll continue afterwards, and we want to prepare you for what comes next. The data science program, the data science minor program, has 5 core courses. At the 200, 300, and 500 levels, you learn to think with data and program with data. You learn to compute with statistical models, modeling data. You learn about data processing and storage, and there's an opportunity for a capstone course where you get to explore data, typically in the context of your major or honors program. Again, the data science minor is meant to interface well with your field of specialization, and as part of the minor program, you have to take a certain amount of breadth courses in order to make sure you're applying the data science methodologies that we teach you to specific domains of interest. There are courses that satisfy breadth requirements coming from almost all the faculty, or almost all the departments in the Faculty of Science, and many faculties outside of science, for instance, management and medicine and engineering. All right, so you get an applied degree, an applied minor that teaches you fundamental tools for working with data and applying those to your scientific interests.
Thank you, Matt. Our next speaker is coming to you from environmental science.
Good evening, everybody. So my name is Dan Sugar. I am the director of the environmental science program. I'm also a professor in the Department of Geoscience. So in the breakout rooms, I'm happy to answer any geo questions that you might have if the folks in the geo breakout room are busy. Okay, next slide, please. So a bunch of the other departments and programs have been under the mistaken impression that they are the most important science of all. I would like to correct that and assure you that environmental science, or ENSCI as we call ourselves, is the center of everything and the best subject to study at university. Next slide, please. So we are bombarded on a daily basis with news stories about climate change and biodiversity collapse and other environmental catastrophes. And if this sort of news makes you feel kind of down, pretty depressed, know that there are careers where you can be part of the change to help make a difference on this one planet that we have. Slide, please. And so the environmental science program is an interdisciplinary degree where you'll learn a variety of different skills and tools for assessing the health of the environment. While many of our graduates spend a considerable portion of their working life outdoors in the field, as is shown in some of these photographs from some of our field courses, there's lots of opportunities as well for office-based work if that's more your speed. So I look forward to chatting with some of you in the breakout room. Thank you.
Thanks, Dan. Our next speaker will be talking about the nanoscience minor.
So, hi, everybody. My name is Simon Trudel, and I'm the director of the nanoscience program. And I'm also a professor in chemistry. Next. So what is nanoscience is usually the first question I get asked. And really, it's the big science of looking at very small things. And to illustrate what I mean by a small thing, I am here showing you a gold nanoparticle, which is a few nanometers in size. And you can see a little scale bar there that's telling you 2000 nanometers, and that is essentially 1 billion times smaller than I am. So you would need 1 billion of these nanoparticles stacked on top of one another to arrive at my height. So why do we want to work with such minuscule objects? One of the reasons is we can make new materials, and with these materials can come new properties, and in particular, new useful properties. And there's a lot of new science coming from these small sizes because we now enter a quantum realm where we have quantum size effects. And there are new challenges to understand all of these things. Nanoscience is applied more and more in a variety of fields. It is becoming a very important component of medicine and in drug delivery. The electronic industry, as your phone gets smaller and smaller, so do the components that are in there. And there's billions of these components. And so they have to be minuscule to fit in your pocket. Clean energy is a field which greatly benefits from new nanomaterials. Areas quantum computing often involves making small materials as well. And they're quite useful materials. You can even, although a lot of these things sound like very high tech, you can make better concrete from adding, for example, carbon nanotubes in them. And so at the University of Calgary, the nanoscience is a minor, which actually is really great. It really complements well with, as you can see, all of these fields really translate to biology, health science, chemistry, physics, or some fields in engineering. Next slide. So our program is really a program that focuses on learning science by doing science. And what that means is you will be involved in doing some research. You will also, we put a lot of emphasis on scientific communication and communicating your scientific results. We touch on entrepreneurship to capitalize on all these great new discoveries and materials we can make. And it is truly a multidisciplinary program. You will get to have to play with hands-on experience with advanced tools, such as here a scanning electron microscope. And finally, to really emphasize the research, some of our students' research projects was novel research that was new that essentially ended up as a scientific publication. So we really put the emphasis on doing new things. You design a research project and you advance nanoscience yourself. So I'll be happy to answer any questions you might have.
Awesome, thanks, Simone. Our next speaker is coming to you from the Natural Sciences program.
Hello, everyone. My name is Bronwyn Wheatley. I am an instructor for the Department of Chemistry and the Program of Natural Sciences for the Faculty of Science. So you have just heard presentations from many branches of our Faculty of Science. I now have a few questions for you. Do you have an affinity for more than one science? Do you have a great interest in one science but maybe find another comes more naturally to you? Do you like all the sciences? In a 4-year interdisciplinary degree, natural sciences allows you to follow up on 2 main science disciplines while sampling still more sciences, as well as some non-science options. Natural sciences has a few of its own courses that explore how different disciplines approach problems so you can benefit from those different ways of thinking. The natural sciences degree could lead directly to the profession that is the combination of your chosen sciences. For example, if you select geoscience and chemistry, you could enter the field of geochemistry. Your degree could also be a gateway to careers such as science journalism or science policy. You could also go for natural sciences into the fields of education, medicine, or other professional schools. In short, natural sciences is a multidisciplinary, unique, and flexible program allowing you to design your own 4-year science experience at the U of C.
Nancy, you're muted.
I'm having a wonderful conversation with myself. Thanks, Bronwyn, for doing that. So our last presenter for this evening is from our neuroscience program.
Good evening, all. My name is Vic Uldering. I'm director of the Bachelor of Science in Neuroscience program. And one of our central mottos is neuroscience from molecule to behavior and bench to bedside in 4 years. That's obviously impossible, but I want to give you some highlights, and then you have the opportunity to ask me more questions later on in the breakout session. So we're a unique program, we're multidisciplinary, and we're unique in the sense that we're a collaboration between 3 faculties and 1 research institute: the Faculty of Arts, the Department of Psychology, the Cummings School of Medicine, and the Hotchkiss Brain Institute, and obviously my home faculty and the program's home faculty, the Faculty of Science. Now, next slide, please. The neuroscience program is a program designed by neuroscientists for neuroscientists, at least neuroscientists of the future. We embrace curiosity. We stimulate you to basically pick your own path and ask your own questions. And actually, those questions can be in the molecular area, but can also go all the way to the cognitive and behavioral areas. So our program is interdisciplinary, as I'll show you in a few minutes, in a minute or so. We have lots of different courses to actually prepare you for a career in neuroscience. So some of the highlights: we're direct entry. We're very small, only about 30 students per year are admitted. We're extremely interdisciplinary, involving multiple faculties and a research institute. We're research intense. We have several research courses. We have a sponsored summer studentship program that allows you to do research in one of our more than 100 neuroscience labs. So we're an honors degree, so you do thesis research at the end of in your 4th year. And one of the things, because we're so small, and we have a fantastic group of students and a fantastic student organization association, there is an incredible strong peer support in the program and tradition in the program. Next slide, please. So we don't have to talk about this in a lot of detail. This is only to illustrate that there is psychology elements, there is science elements, there are dedicated neuroscience courses in our curriculum. And it's put together to really cover that interdisciplinarity. And it's actually also obviously covering the research intensity of the program. Now, this is what we're currently doing, but changes are on the way. We're going to be creating some changes. We're creating more flexibility, more science options. We're branching out, and we're talking with our other departments in the Faculty of Science: computer science, data science, complexity sciences. But we will remain that same interdisciplinary, research-focused, hands-on foundation, hands-on experience foundation. Next. So, you want to know how the brain works, or why things go wrong occasionally. You want to be able to do something about that, fix things when they're going wrong, or you're simply fascinated by what that fantastic brain of ours can do, all the mysteries and of the mind and brain that we haven't answered yet. We have a long way to go. And actually, a quote from Christoph Koch, a researcher looking at trying to understand the foundations of consciousness, think about that, says, well, listen, we don't even understand the brain of a worm. So let's be honest, we still have a lot to do as neuroscientists. So you're interested in this kind of stuff. Next slide, please. Then, yeah, consider the neuroscience program. Join the team. We're going to have a lot of fun and we're going to do some really interesting stuff. Not only science, as you see here, we're also doing some amateur geology, hiking around in the Rocky Mountains, etc., etc. Okay, thank you. Hope to see you in the breakout session.
Okay, I've unmuted myself this time. So thanks, Mike. That was fantastic. So I'm going to stop sharing my screen so that now you can see us all. So that wraps up. I lost my cursor here. So this wraps up our shorter presentations. So I want to thank everyone for joining us tonight, and a big thank you goes out to all our panelists and your presentations. And everyone thinks they're the best science, and we're all part of science, and science is awesome, and science is the best.